All right. So, a couple things before we get started. Um, we're going to dive into Module 11 monopolies here today. I'll kind of revisit some things about perfectly competitive markets, reviewing things along the way. I know I had this Excel file that we didn't get to last week. I'm going to actually incorporate it into what we're talking about with monopolies today. So this Excel file blank, this monopoly blank, we'll use this at the end of class. Um, might even spill over into Thursday's class. So we're just going to get some review of monopolies and perfectly competitive firms with it. But just a kind of taste of how you would do this in Excel as opposed to doing all the work by hand in a calculator. Another thing that you'll see an announcement pop up, I think after class today, I have it set to be at 11. So in reviewing the exam and going through questions with different students, there's one question which, as I review it, if I'm being completely fair, I think could have been interpreted a slightly different way. So it was a two-part question, so it only applied to the second part of the question. So what I did was I went through and I didn't treat that second part of the question as being part of it. I gave it, but treat it as though everyone got the second part correct. Then based off of that, there really were two correct answers to the problem. So this only impacted, I think it was in this section, like 25% of you would have been marked incorrect when it, in fact, would have been one of the two correct answers. So for 25% of you, you might see if you look at your exam 2 score where you go on grade scope, it may have one additional question that you got correct. Now, once again, that's only 25% of you. The vast majority of you got the question correct, actually, the way that it was intended. But because that second part could have been interpreted slightly differently, once again, I accepted 2 answers for that question. It should now be reflected in grade scope. You can kind of check on your exam score if that was, applied to you. Okay. It really didn't impact the overall mean too much. But you'll see that announcement pop up after class. Okay. Other than that, we don't have any new assignments. Nothing's kind of open after Thursday's class. We'll have a new quiz, new module reading, and I'll also post up the next Canvas discussion, which I talked a little bit about last week. It's going to look a little bit different than the other ones. I'll dive deeper into what that's exactly going to look like in Thursday's class because it's related to monopolies and what we'll talk about this week. Okay, so see all 3 of those things pop up on Thursday. That Canvas discussion, I'll give you a little bit more time to work on. That'll be due at the end of the week next Friday. Okay, so that's kind of where we're going. That's our roadmap. Any other questions for me before we dive into material here today? Okay, so we'll kind of start looking at, instead of perfectly competitive firms, we're going to look at monopolies, right? So you've probably played the board game or you've heard this term used. What does a monopoly mean? There is only one firm or one seller of this product. Okay, so how can this exist? If we go back, an age-old example is someone owns a key resource, right? If you go back 100 years, I think this might look a little bit different now, but like one company owned all the diamond mines in the world. So if you wanted to produce diamond rings, you had to source or you had to buy them from this one company. They had complete control over the kind of equilibrium price of diamonds. Okay? Another way this can exist is if the government gives exclusive rights. So the best example of this is the post office, right? Especially if you go back further in time, you wanted to send anything, you had to send it through the post office. Now we have things like UPS, FedEx, but technically they can deliver packages. And if you put mail in one of their envelopes, they can deliver that. It's kind of their way around it. But the only person who can deliver first-class mail is the post office in the United States. Now, outside of the United States, there's a lot of other examples where the government gives exclusive rights to one company to sell one product, right? So there's sometimes government rights that are given. This can be done at the local level as well. Sometimes different utility companies are given the rights to provide electricity in this one area or whatever the case may be. Now, what's more likely the case with electric companies, or if you think about like cable companies, is it's really expensive to create electric power lines. It's a huge fixed cost. So when there's one firm, maybe they can earn positive profits, but as soon as a second firm enters, both their profits go to become negative. If there's negative profits, what will one firm do? Exit the market, we're left with one. So sometimes we have what we call natural monopolies. We'll look at these more specifically on Thursday's class, but that's another reason why we can see these monopolies exist. So given that one exists, the kind of traits of monopolists, unlike a perfectly competitive firm, we don't have many firms and many buyers. we have one producer, one seller of the product. This means that we have no competition, right? So no competition. Do you think, just as a foreshadowing, what do you think a company can do if they have no competition? Charge a higher or lower price? Higher. This is fairly intuitive. Now we'll see why using our models here throughout today's class, right? So when we go back to a perfectly competitive firm, we're going to make this comparison of monopoly to a perfectly competitive firm a lot today. So we'll be doing a little bit of almost like review from last week as well. So we said that what does a firm in a perfectly competitive market have to do? They have to take the equilibrium price as given. This is the example of a gas station. If I increase my price and there's 4 gas stations in the same area, what's everyone going to do? Go to the other gas stations, right? So I can't charge a price anything other than that equilibrium price. So my demand curve is essentially, as a firm, is horizontal. If I charge any price higher than this, I'm going to sell 0. Now, if I charge the equilibrium price, I can sell different quantities of this product, right? But really, a firm in these perfectly competitive markets, and we did this last class, is facing a horizontal demand curve. And that demand curve, if I can't get away with charging anything other than the equilibrium price, that price becomes my marginal revenue. Right? So we've got kind of the firm demand from a perfectly competitive market, nice horizontal demand curve. I can't increase my quantity if I increase price, I can't change my quantity if I increase the price because I'll just go to selling nothing. Okay? So in the long run and the short run, for a perfectly competitive firm, whatever that equilibrium price was, that was the marginal revenue they faced. It was nice and constant. Okay? For a monopolist, it's going to work a little bit differently. A monopolist is the only seller of a product, so they're going to face the entire market demand curve. What is market demand? That's our old demand curve. It's always going to be downward sloping. As the price goes down, more people want to buy this good. Okay? So the monopolist faces not a horizontal demand curve like a perfectly competitive firm. They can change the price. They're the only person selling it. And as they change the price, consumers are going to want to buy more or less. So they face the entire demand curve. It is their firm's demand curve as well. There's only one firm. Okay? So what we'll end up seeing play out is that the price they set is not the same thing as their marginal revenue. So it's going to work a little bit differently than perfectly competitive markets. Okay. So we'll work through a kind of example with some numbers. I'll then go through some more, I don't say complicated, but a little bit more complicated stuff to kind of support this. But we'll just work with some basic numbers first. So if I've got price and quantity combinations, this is the quantity demanded. This is the price. This represents my demand. If I wanted to calculate total revenues, we said total revenue is always going to be equal to my price that I'm charging times the quantity I'm selling. So price times quantity, if I wanted to fill in total revenue here, if I set the price at $4.50, I sell nothing, my total revenues are 0. If I lower the price to $4, I now sell a unit. So now my total revenue would be 4 times 1 or $4. Now, if I lower the price a little bit more, is lowering the price a good or a bad thing for my total revenue? Initially, you might think, well, if I'm charging a lower price, I'm making less per unit. So my total revenues, that's going to hurt them. But by lowering the price, if I sell a lot more units, selling more units is actually going to cause total revenues to go up. So in this case, if I lower the price from 4 to 350, what is my total revenue now? 2 times 350 would actually be 7. So notice, as I lower the price, initially, what is happening to total revenue? It's going up. Now, there becomes a certain point where if I lower the price anymore, I'm not convincing consumers to buy that much more of the product. And so there, the decrease in the price kind of like cancels out the increase in quantity. So at a certain point, my marginal revenues will start to, my total revenues will start to go down. Well, before we actually calculate them, right? Well, hold on a second. Sorry. I've got another column first. We're going to reuse a lot of the same things we talked about with cost, but applying to revenues. So how would I calculate an average revenue? Well, what was average total cost? It was my total cost divided by quantity. What do you think total revenues are? Or sorry, average revenues are? My total revenues divided by quantity. So if I go through here, 4 over 1 is 4, 7 over 2 is 350. Notice what's true about my average revenue. It's the same as my demand curve. Now, what about marginal revenues? Well, before I even calculate them or think about how to calculate them, what does marginal anything mean? It's the change in that thing. So marginal revenue is the change in total revenue coming from a change in quantity. As I sell more units, initially total revenues are going up, so my marginal revenues would be positive. Change in total revenue, marginal revenue is the change in total revenue. If it's positive, that means my total revenues are going up. Now, at a certain point, once my total revenues start to go down, there my marginal revenues would actually be, my total revenue is going down, that change is negative. Now, how would I actually calculate marginal revenue? Just like marginal cost, it's not, the marginal cost was the change in my total cost divided by a change in quantity. Marginal revenue is going to be a change in total revenues divided by a change in quantity. So here, if I go from a quantity of 0 to 1, total revenues go from 0 to 4. So 4 over 1 is 4. What if I go from 1 to 2 units? Change in total revenue is 3 divided by a change in quantity of 1. Here it's easy because the quantity changes are 1. That would be 3. So if I kind of keep on doing that, calculating these marginal revenues, sure enough, anytime total revenue was going up, that meant my marginal revenue values were positive. Now, if total revenue doesn't change, that means my marginal revenue is equal to 0. And then as soon as my total revenues start to decrease, that means my marginal revenues must be negative. Okay? So you'll notice here, even though average revenue was the same as my demand curve, essentially, those prices, marginal revenue is always below those prices. So if I were just to plot these out, I could plot out my demand curve, and then also on the same graph, plot out at these various quantities what my marginal revenue values were. So if I do that, I've got my demand curve. That's using the prices and quantities. If I wanted to graph out marginal revenues for every quantity, I'd just be using my marginal revenue column to now kind of plot these points. And what I'll see is that my marginal revenue curve is always below my demand curve. So when we're looking at a monopolist, because they're choosing the price, they don't have to take the price as given. Their marginal revenue curve is not horizontal. It's actually downward sloping as well. And it's always going to be below my demand curve. So why is that the case? We'll kind of talk a little bit more in a second here, but for now, just trust me. Okay? So marginal revenue for a monopolist, always downward sloping and twice as steep as our demand curve. Why twice as steep? We'll see in a second. Okay? Any questions before we keep moving here? And once again, I calculated the marginal revenues here, so that's where these points come from. I'm not just making them up. So if I'm thinking about the monopolist marginal revenue, it's always going to be less than the price they can charge, or it's going to be below that demand curve. It's lower than the demand curve, it's downward sloping, and it'll be twice as steep. So we'll see why in a second here, but these are going to be kind of the main characteristics of my marginal revenue curve for a monopolist. Now, why is it twice as steep? So I've got some work in here, but we'll kind of think about this a little bit more in depth. Okay. All right. So if I'm thinking about my total revenues, right? What are those equal to? We said that's equal to my price times quantity. One way that we can write out our demand curve or our demand equation was price as a function of the quantity that people are buying. Now, we said B is always going to be negative because if I want to sell more units, I have to lower the price. Okay? So what I'm going to do here is say, okay, look, the monopolist is setting the price. They don't have any competition. They get to set the price. So what are they setting the price based off of? That demand curve, right? If I'm choosing the quantity I'm producing or I'm choosing the price, there's going to be a corresponding, if I set the price, corresponding quantity. If I set quantity, there will be a corresponding price at these different points in the demand curve. So I'm going to plug this in, and I can think about, here's my total revenue. All I did was plug in for price what that demand curve is. That's how I'm making my pricing decision. Well, if I want marginal revenue, this is where if you've taken hopefully a calculus course, I'm not making it this complicated in class, and I won't ask you to do this, but I'm using this as to kind of support, and most of you can hopefully can connect with this if you've taken any level of calculus. If I'm thinking about a marginal change in something or a change in my total revenue coming from a change in quantity, what does this look like or sound like? A starts with a D, derivative, right? How would I take a derivative of total revenue in respect to quantity? Well, maybe it helps to rewrite this. Just kind of distribute quantity here. How would I take a derivative of this now? Okay, I'm going to be left with A plus 2 times B times quantity. So all marginal revenue is a change in total revenue coming from a change in quantity. That's essentially a derivative of our total revenue equation in respect to quantity. That's all I've done here. Well, now notice, this is my marginal revenue equation. If I'm thinking about graphing out, right, putting this, oh, well, this is my demand equation. It starts out at A, and the slope is B. What if I were to put my marginal revenue equation here? Well, it starts out at A, and its slope is 2B, right? So it's always going to be twice as steep. Right? So anytime I'm looking at my demand curve relative to my marginal revenue curve, marginal revenue, that value of B is always negative, right? Because we knew the relationship between price and quantity demand is negative. And my marginal revenue curve will always be twice as steep or below our demand curve, okay? Now, once again, I'm not going to make you take these derivatives. We're going to keep everything kind of nice and linear. So I can just go back to kind of calculating this as my marginal revenue is the change in total revenue coming from a change in the number of units I want to sell. Okay? Any questions on anything here before we keep moving? Okay. So I think, all right, I'll jump the gun a little bit before we go back to the slides here. But with this in mind, if I have my total revenue equation, that's going to be price times quantity, right? So if I'm thinking about if I lower the price, okay, that's going to have different impacts on my total revenue depending on where I'm at on my demand curve, okay? So if I lower the price by a little bit, and in response, people buy a lot more of this good, we would call this kind of the price effect. And over here, this would be the output effect on total revenues. So in this kind of a scenario, if I lower the price by a little, that hurts my total revenues. But if people buy a lot more, that's going to help my total revenues a lot. So I could see that my total revenues in this scenario go up, right? Now, I could also have a situation where I still have my total revenue equation. I lower the price by a lot, but I haven't convinced consumers to buy that much more of the product. So here, which kind of effect, price or output, is larger? Well, if the price effect is larger, I'll actually see my total revenues go down. And in this case, our output effect was larger. So depending on where I'm at on my demand curve, or depending on the response of consumers, that same price decrease could cause a different change in my total revenue. Or here, if I'm lowering the price and total revenues go up, what would be true about my marginal revenues? They would be, well, if total revenue goes up, the change in total revenue is positive, right? Here, if I lower the price and the change in total revenue is going down, my marginal revenue must be negative. And that's where in that table, remember, for some quantity price combinations, if I lower the price, marginal revenue is positive. For other points, when I lowered the price, marginal revenue became negative. So if I'm thinking about here, a change in price and it matters about its size relative to the change in the quantity. What does that sound similar to? Elasticities. So this is where the final exam is not going to be cumulative. I won't go back and ask you Module 4 type questions, but we're using the concepts we talked about in Module 4 in the context now of a monopoly of maximizing profits by the end of class. So we're reusing these principles of elasticity. So I'll kind of move a little bit here, and we'll look at this in the slides, probably a more complete version here. So let's think about if I've got something like this, okay? So I've got my demand curve. I've got my marginal revenue curve, okay? There's going to be some point, I drew it off a little bit, sorry. There's going to be some point on my demand curve where we are unit elastic, or my elasticity would be equal to what? 1, right? So I can think about at that unit elastic point, what is my marginal revenue going to be? Well, here we kind of have a third scenario. What if I lowered the price and as a result, I saw the same kind of change in quantity in the opposite direction? Well, their total revenues are staying the same, or my marginal revenue is equal to 0. So I'm at that unit elastic point, my marginal revenues are going to be equal to 0. Now, this is where we have to go back, revisit what we talked about in Module 4, but this was kind of hopefully an intuitive result. If this is my unit elastic point, every point above that on the demand curve, my elasticity measure is higher than 1, or I would be on the elastic portion. Now, if I'm on the elastic portion, what I could think about is, okay, if I'm on the elastic portion here, I know my elasticity is greater than 1. Our elasticity of demand was the percentage change in quantity demanded over a percentage change in price. Whereas if this is greater than 1, what that implies is that percentage change in quantity must be greater than that percentage change in price. Okay? If that's the case, I could think about something like if I lowered the price by 10%, what do I know has to be true about the response of quantity? It's going to go up by something larger than that. So here we'll just kind of use the hypothetical value. It goes up by 20%. So that price impact lowered my total revenues, but the increase in output was even larger. So what's going to happen to my total revenues here from a price decrease? They're going to go up. So anytime we're on the elastic portion of the demand curve, total revenues would go up, or what's true about marginal revenues here? They're positive, right? It's going to cause total revenues to increase, which means marginal revenue is positive. Okay. Now, if I instead think about if I'm somewhere down here, my elasticity measure is lower than 1, or I'm on the inelastic portion of the demand curve. So if I kind of use that same thought experiment, if the elasticity is less than 1, and I just rewrite out what my elasticity is, that's going to imply that that numerator is actually less than my denominator, right? So if I were to lower the price by 10%, now the response in quantity, if I'm on the inelastic portion, I know is going to be something less than that 10%. So the same kind of 10% price decrease here is going to cause my total revenues to go down, or my marginal revenues at these quantities are negative. So anytime I'm on the elastic portion, lowering the price actually increases my total revenue or has a positive marginal revenue. Any point past the unit elastic point, when I'm on the inelastic portion of demand, there, if I keep lowering the price, total revenue is going to go down, or my marginal revenue becomes negative. Okay. Any questions on this idea before we keep moving? Okay. So this is going to be kind of some reasoning behind why that relationship exists. I initially said we can kind of think about before we even got to elasticities, our total revenue as we change the price, that's going to cause a change in total revenues. But anytime I change the price, because I'm facing the entire market demand, that's going to move me to a different point on the demand curve. Changing price will also inherently change the quantity I can sell. So there'll always be this kind of price output effect. And we don't care just about the change. We care about what that percentage change is. That's why we were then looking at elasticities. So we already kind of built this out. Now, just as kind of a checkpoint, what's the lowest my marginal costs could ever be? 0. How do firms make decisions? And we'll look at this here in a second more in depth. But I said get this tattooed on your arm, right? Same thing as a perfectly competitive market. A monopolist acts the same way to maximize profits. They set the quantity where marginal revenue is equal to marginal costs. If my marginal costs are 0, where does that hit my marginal revenue curve? At the unit elastic point. If my marginal costs are at anything, so even slightly above 0, where am I going to hit my marginal revenue curve? On the elastic portion of my domain. I can never, unless like marginal cost being negative would mean like someone's paying me to produce, like, I don't even know what that would conceptually look like, right? So for monopolists, marginal cost, even if it was 0, is always going to hit our marginal revenue curve at the very worst at the unit elastic point. And as soon as we have any marginal cost, which there's nothing where you have a 0 marginal cost, but just using that as kind of a reference point, any marginal cost would then result in us choosing a quantity where we're at the elastic portion of our demand curve. Okay. Any questions on that before we keep moving? Just kind of adding something in there to kind of think about. So I think the next slide I left blank because we then want to try to connect this idea to what's happening to total revenues, just to kind of give us a nice visualization. Right? So if I think about this idea where I've got my demand curve, there's some point in the middle where it's unit elastic. Every point up here, we said it's elastic or elasticity of demand above 1. And every point down here, we said is inelastic or the elasticity is less than 1. We then drew in, okay, I got close there, right? Let's assume that's right there. We have this twice as steep marginal revenue curve. Okay. I want to map this out instead at these various quantities. If I'm setting this price and the resulting quantity as a monopolist, because I have complete control in the market, what's that going to do to my total revenues? Well, just as a reminder, visually, marginal revenues for all of these quantities are above 0. Right? In fact, I'll color code this. Every quantity over here, my marginal revenues are negative. So if I charge this price and sell 0 units, what is my total revenue? If I sell nothing, my total revenue is 0. Right? As I lower the price, sell more units, what's going to happen on the elastic portion? Well, if marginal revenue is positive, that means the change in my total revenue, it must be going, sorry, marginal revenue is the change in my total revenue. So if it's positive, my total revenues must be increasing, right? Now, this is a little bit past what I would kind of push you on a quiz or exam, but what's happening to my marginal revenue value? It's becoming smaller and smaller. So essentially my marginal revenue is the slope of my total revenue. So that change in total revenue is becoming smaller and smaller and smaller, or it's getting flatter, right? Until I get to that unit elastic point. So that unit elastic point is going to be where my total revenues are actually maximized, right? Lowering the price here, increasing quantity, was causing total revenues to go up. Now, if I start to lower the price anymore past this point, yes, I sell more units, but I'm now on the inelastic portion of the demand curve. Marginal revenue is negative. It's becoming a larger negative value. So if I now increase quantity here, my total revenues, if the change is negative, my total revenues must be going down, right? So here I have completely two different effects. If I lower the price and I'm on the elastic portion, my total revenues were going up. If I'm on the inelastic portion and I lower the price, my total revenues were going down. Okay. So this is kind of our relationship between the demand curve, our marginal revenues, and what that means for our total revenues. Now, I like this depiction because it kind of helps me see. If I'm on the inelastic portion of the demand curve, well, what do I want? I want higher revenues. So if I want to increase my revenues, if I'm on the inelastic portion, what should I actually do? Raise the price and sell fewer units, right? If I do that, I move towards this point where total revenue is maximized. If I'm ever on the elastic portion, how do I maximize total revenues? I have to move towards that unit elastic point. So if I'm on the elastic portion, I need to actually increase quantity, which I would do by decreasing the price. Yeah. If I was trying to maximize the total revenues only, I would end up at that unit elastic. Now, what do you think the firm is actually going to maximize? We haven't factored in yet. Profits. So it'll look a little bit different, but we want to kind of think about how the elasticity of demand is going to influence the revenues of the monopolist. Because what matters for profits, revenues and costs. Right? So just now we're just honing in on the revenue portion or side of things. Okay. Any other questions on this before we keep moving? Okay. Excuse me. All right. So kind of let us into the next thing. We don't just care about revenues, right? We care about what profits are. Okay. So we said a perfectly competitive firm will maximize profits where they'll set the quantity where marginal revenue is equal to marginal cost. Now, for a perfectly competitive firm, marginal revenue is simply the equilibrium price. What we just saw from monopolists, marginal revenue at different quantities is actually different values. So they would still set the quantity where marginal revenue is equal to marginal cost. It's just that marginal revenue is not the equilibrium price. It's now this twice as steep downward sloping marginal revenue curve. Okay. Now, once they select that quantity, how do they then figure out what price do I need to set to get that quantity sold? What they'll end up doing is once they choose that quantity, they'll actually go up, figure out, well, at this quantity, what is the last consumer willing and able to pay? What does that sound similar to? What represents the ability and willingness to pay? So supply represented the ability and willingness to produce these units. What represents the ability and willingness to pay? Demand, right? And so we'll go up to that demand curve. So what is this going to look like? And I've got some stuff in the slides. We'll start building this out. I think it'll be helpful to kind of review two scenarios because there's something else I want to point out in the slides that I wouldn't have here, okay? So if I'm looking at, I've got my demand curve. I've got my twice as steep marginal revenue curve. Now, one thing we didn't have built in here. Yeah, so this is what I want to make sure. So one thing I didn't put into my earlier model is, well, what matters for profits? Marginal revenues, but also marginal costs. So if I had this kind of marginal cost curve, how would I choose the profit maximizing quantity? So remember, we're still going to calculate profits the same way, okay? So for right now, we're thinking about how do I maximize profits? Well, I'm going to actually choose the quantity where marginal revenue is equal to my marginal cost, right? that's going to be down here at this quantity. Okay. Now, if I was choosing this quantity, why would I charge this price? So unlike a perfectly competitive market where they would simply set price equal to their marginal revenue, well, at this quantity, I know consumers are willing and able to pay what? This much higher amount. So if I'm the only firm, why would I charge a price that's lower than what consumers would be willing to pay? I wouldn't, right? If I'm trying to maximize profits, I want that price to be as high as possible. So I'm going to set it as high as I possibly can at this quantity, which is how much are people willing and able to pay. So our kind of steps here to maximize profits are first, kind of choose that quantity where marginal revenue is equal to marginal cost. The second step that a monopolist will have to do is then set the price at that quantity where we're at on our demand curve. Okay. So for a monopolist, it's kind of a two-step process. Okay. Any questions on this before we keep moving? All right. We're sure there's no questions here. I'm going to add something in here. So if I'm calculating profits, what's the other thing that matters? What are my average total costs? So let's assume here, and in the slides, I'll kind of mention why I'm exactly drawing this here. But let's say I have my average total costs. And marginal cost hits them at what? Reviewing what we talked about with costs, marginal cost hits average total cost at its minimum point. Now we said in module 10, perfect competition, that lowest point of my average total cost actually represents the lowest possible per unit costs. Okay? So if I'm at the lowest possible per unit costs, that would represent where I'd be at in a perfectly competitive market. Now the monopolist is going to be up here. So notice, at that quantity the monopolist sets, the value of average total cost, now I drew it kind of weird here, it's slightly higher. It's kind of hard to see with my visual. That doesn't matter for right now. But here, I'm looking at the average total cost at this quantity. Well, what's the area of this rectangle represent? The height is the difference between the monopolist price and average total cost. The width is the quantity that the monopolist is selling. So this rectangle represents the profits of a monopolist. If price is above average total cost, those profits are positive. Okay? So even in the long run, so let's just assume I'm in the long run, average total is equal to average variable costs. The monopolist can actually earn positive profits. Okay? Okay, so make sure I'm keeping an eye on time. So the only way this can occur is if other firms can't enter this market, right? One thing I didn't mention earlier, it's not really a government issue. It kind of is a government issue thing. But another thing that caused monopolies could be something like patents, right? So it prevents other firms from entering this market, which monopolists like because they now have positive profits, right? And we know the profits in the long run of a perfectly competitive market will be equal to 0. Okay. Any questions here before we move back to the slides? So I kind of have a similar depiction, right? If we're thinking here about the marginal cost, and usually like I'll ignore the gains from specialization part of the marginal cost curve just because if we have gains from specialization, it always makes sense to know our costs, right? So here we're kind of just focusing on that diminishing returns portion. So the steps are I first choose the quantity where marginal cost is equal to marginal revenue. I then set the price, whatever consumers are willing to pay, which is up at the demand curve at that quantity. I then would kind of compare, if I had my average total costs, that price to my average total cost to calculate profits. So this is simply how I set the price and quantity. I went kind of one step further when we were drawing it out. So intuitively, what is going to happen if I'm comparing the perfectly competitive market to a monopolist? Well, we said earlier, very first start of class, if I'm a monopoly, do I charge a higher or lower price than a perfectly competitive market? Higher. Higher. Now, if I charge a higher price, I'm moving to a higher point on my demand curve, so I also know if I'm charging a higher price, quantity in the market is actually going to be lower. So how would we look at this visually? Okay. So I've got this kind of side-by-side comparison. But if we just think about a perfectly competitive market, the market itself arrives at the equilibrium where supply is equal to demand. This is like module 3, right? So here's our perfectly competitive industry. The market arrives at this point where supply is equal to demand. If I'm comparing this to a monopolist, the monopolist still faces the entire demand curve. So if we kind of switched over the thought experiment, take a perfectly competitive market, now there's only one firm. And maybe the government takes over this market. We see that in other countries, right? What does my supply curve represent? Demand represents marginal benefits. Supply represents marginal costs. Well, if I only have one firm, their marginal cost curve essentially becomes my market supply. So if this was a perfectly competitive market, where would the equilibrium be? Well, if marginal cost is only one firm that represents the supply in the market, simply where my marginal cost or my supply would be equal to demand. So I'm using C here. This is like the perfectly competitive price and quantity. Now, because monopolists make a decision not based off of the demand curve, but a twice as steep marginal revenue curve, the point where marginal revenue hits marginal costs will always have to be at a lower quantity. So we're always going to choose kind of this lower quantity. And then if we go up to the demand curve, just by like the nature of how math works, I have a twice as steep, I'm always going to be at a higher price. So the monopolist will always choose a higher price and set a lower quantity relative to these perfectly competitive markets. Okay. Any questions on this idea before we keep moving? Okay, so kind of already mentioned these. We'll skip these questions for today. We might revisit them next class. I'll kind of use this to kind of then make a couple more points before we kind of move on. Okay. So I'm now going to add in my average total cost curve. And we already did this earlier to think about profits. But I want to make a point here that I didn't make before. So if I was looking at a perfectly competitive market, we just said the equilibrium point, or where the market gets to, will be where supply is equal to demand, where we only have one firm, marginal cost is a supply curve. So the perfectly competitive market would actually be out here. Where does marginal cost hit average total cost? At its minimum point. Or the perfectly competitive market gets our per unit costs to be as low as possible. Does that sound like a good or a bad thing for a society or the market? Good thing. We've gotten our per unit cost as low as possible. If we compare that to a monopolist, okay, well, first of all, before I go to that, one more thing I want to mention. At that perfectly competitive point, what's true about the price the perfectly competitive market would choose relative to the average total cost? They would be, if the price is where supply is equal to demand, it's exactly equal to average total cost. So profits here in a perfectly competitive market would be equal to 0. So I must be in what? The perfectly competitive market, we have to see 0 profits. Are we in the long or short run? Long run. So looking at where that perfectly competitive point is, we know we're in the long run here. Now, where would the monopolist choose the quantity and price? Well, they face a twice as steep marginal revenue curve. They'll choose this lower quantity, then go up to the demand curve to set that price. If I now think about what are my profits for the monopolist, it's the quantity they choose times the difference between the price and the average total cost at that quantity. So here we said profits for the monopolist can be positive relative to the perfectly competitive market in the long run we know profits are equal to 0. Okay? So the monopolist can exist in the long run with positive profits. Perfectly competitive market, we said in the long run, profits always get driven by firm entry and exit down to 0. But a monopolist, we have either government rights, ownership of a key resource, natural monopolies, or I kind of mentioned the other one was patents. That can all prevent other firms from entering that market. Any questions here before we move on? Okay. So where are we at on time? Oh, we got tons of time. Let me think if there's anything else I want to say here. We'll revisit this next class. So we'll jump right in. Oh, before I do this, I should probably set the time. So let's say got here, we're going to do 10. Well, so we kind of have the next 8 minutes. You can find this on the home page under the quizzes tab, in-class quiz 11.1. We're going to go to build here. So you can see this. I believe the code is 56.57, right? Or 56.57, okay? So you've got 2 questions here. The first one, I'm asking you to identify the price and quantity. The way in which I wrote this, it's reverse. So I use dollar signs. That should be the price, right? So what's the profit maximizing quantity and price the monopolist will set? And then as a result, what will the profits of that monopolist be? So I'll give you guys a little bit of time to work on this. What's up? Oh, 57.56. Is that working? Yeah. Sorry. I try to do this from memory. Sometimes I mix it up. So 57.56, sorry, is the code that will get you in. Okay. So take the next 5 minutes or so, work with the people around you. You don't have to be quiet here. So 57.56 will get you into this quiz. I may not be reviewing this one, so maybe put some time and effort in, kind of talking to the people that you're working with to try to get these correct. And I say I won't be reviewing them before the due time. Sorry. Yeah. So no, so they're, when I say they're mixed up, they don't follow the same order, but I use dollar sign. So this first thing is quantity, then this should be the price. Yeah, I use the dollar signs just to note that, just so there wasn't any confusion. Yes. Like this one actually, yeah, All right, so I've got this open for another 3 minutes. So here I'm going to mention something. If you ever have a technical issue with a quiz, when do you think you should let me know? Immediately after class. You send me an email saying, oh, something happened and I didn't get submitted. Got a lot of these emails. When I go in and I see that you started the quiz after 11:29 and you took 30 seconds to complete it, what do you think I think? How long has it already been open? For 5 minutes? So you must not have either been paying attention at all in class or you weren't here, right? So don't email me if that's the case. I don't want to have to call you out, but if you have a technical issue, you need to let me know immediately following class, right? I give you plenty of time to kind of get on, work on this, get it submitted. You still have 2 more minutes. I would hit submit now, right? I'm going to review this. We will not have gotten through these questions by the time I'm done reviewing. So you're not going to be able to wait to hear the answer from me. So make sure you're hitting submit and getting it submitted before this due time of 10:29 today. Okay? Is that fair? Yeah? Okay. So before we kind of get to these actual questions, I want to point out a few things about this depiction. So I basically kind of redrew it here. But if I was thinking about where the perfectly competitive market would be, so a perfectly competitive market, all of marginal cost would represent supply. We have one firm, our marginal cost would represent all of supply, right? So the perfectly competitive market will end up where supply is equal to demand. This is going to be right here. So we would kind of call this the perfectly competitive market. Right? Now, at this point, what is true about the perfectly competitive market? That price is above my average total cost. So profits here for the perfectly competitive market would be what? If profits are always equal to the quantity we sell times the difference between price and average total cost, profits are going to be profits will be positive. So am I in the long or the short run here? Short run, because we know in the long run, firms will enter and exit this market until we get driven down to that minimum point of our average total cost curve, right? Or profits are equal to 0. Sorry, I should say as firms enter, we had positive profits. The price gets driven up till we have profits equal to 0. So we know we're in the short run here, but where would the price and quantity be if we had a monopolist instead of a perfectly competitive market? Well, where marginal revenue is equal to marginal cost, which ends up being at a lower quantity, they then go up to the demand curve, set a higher price. Now, what's interesting here is, like, I could think about before, even if I was comparing the short run profits to the short run profits of a monopolist, it might be hard to say, okay, which of these rectangles is larger? Well, here, why would the profits of a monopolist always be greater than the profits of a perfectly competitive a perfectly competitive firm? This would actually represent the profits that exist in a perfectly competitive market total. What is that being split between? A bunch of different firms, right? So even though like the total profits in the market might be similar, we know that in the monopolist market, the profits will always be higher, okay? Because they don't have to split profits with anybody. So hopefully, based off of what we just went through, kind of the stuff that we did leading up to that in-class quiz, it should be fairly easy to identify this. I shouldn't say things like easy, but we should know how to identify the monopolist profit maximizing price and quantity. So the first thing they have to figure out is what quantity would maximize profits. Okay. So that's going to be simply where marginal revenue is equal to marginal cost. Every firm makes that decision the same way. So we go down here, that looks like it's at a quantity of 15, right? Now, once again, I could look at the perfectly competitive point simply where marginal cost or supply is equal to demand. That quantity would be 22.5 and the price would be 27.5. Well, we said the monopolist should always choose a quantity that is lower. So we know it should be lower than 22.5. We could rule an answer out like 25 as the output right away. Now, if we actually look for the quantity where marginal revenue is equal to marginal cost, there it's at 15. We then don't set the price at 20. In fact, if the perfectly competitive price is 27.5, the monopolist should always set a price that is above that. If I charge that price that's equal to marginal revenue, that's equal to marginal cost for the monopolist, I'm leaving money on the table. I could get away with charging consumers whatever their willingness and ability to pay is, which is up here on the demand curve, which looks like it's at a price of 35, right? So they'll produce 15 units and they would set that price at $35. Okay. Any questions on that before we keep moving? Now, the second question is the exact same graph, but we're asked about profits. Okay. Well, we already know the price and quantity now. The quantity was 15, the price was 35. What's the third thing we need to calculate profits? Profits are the quantity I'm selling times the difference between price and average total cost. The difference between price and average total cost, we can almost think about it as how much on average are we making, or what profit on average are we making per unit we sell. Take that times the number of units, that would give us profits. So we still need average total cost, and we look at the average total cost at that optimal quantity. So at the optimal quantity of 15, our average total costs are 25. So price at 35 minus the average total cost of 25 would be 10 times the number of units we're selling, 15, should give me a profit value of 150. Okay. Any questions on that before we keep moving here for the rest of class? Okay. Is this making sense? I heard some murmurings here. Is this better than Top Hat? Okay. Okay. I heard the chuckles. I'll take a yes, right? So another thing that we're going to do today. Oh, now I forgot. I did this for the other class. So we're going to delete all of this. Opening up that monopoly example blank. In fact, I think this was also left out. Okay. We're going to see how we can fill in this table. So I put up the complete version. We won't get through it completely today, but I want to start to think about, we can do these calculations by hand, but in practice, you would use something that can do the calculations very quickly. Now, will you be using Excel? Probably not. You're going to start to like progress throughout college to things like R and Python, maybe SAS. So it just depends on kind of what course you're taking, what program they're going to be using. But we can kind of deal with large data sets and have this done pretty quickly. Excel is just a very first look at this, okay? So if I wanted to calculate total revenue, first of all, I give you these different prices and quantities, and I just realized I deleted too much here. Sorry. What was in the original file I gave you, I also gave you total costs, okay? So what is the combination of price and quantity? That would be my demand curve. So I've got my demand. If I've plotted out these prices and quantity demand, I have my demand. If I wanted to then calculate total revenues based off of this demand curve, how do I calculate total revenues? Simply my price times quantity. Well, if I've got prices and quantity, I could take my price, multiply it by the quantity. So what Excel does, instead of typing these numbers in, I can use cell references. Then when I copy them down, it just kind of starts to update them. You haven't used Excel. If you have, this is like, yeah, we'll know, I know how this works. But if not, I'm using this general equation. When I then drag it down, it updates those cell references and makes all those calculations for me very, very quick. Doing this by hand would take a lot longer. Now, if I have my total revenue, right, and I have my total costs, how could I calculate initially my profits? They're simply equal to, so this isn't the equation we've been using, but what's another way we can calculate profits? Simply my total revenues minus my total costs. Okay? So we'll kind of ignore these cells that are updating for a second here. Okay? Now, if I'm instead looking at, okay, how do I calculate my marginal revenue? Okay? Well, what is my marginal revenue going to be? It's going to be a change in my total revenue divided by a change in quantity. So what does that look like? And I got someone asked me last class, why am I using parentheses? Because I need to make sure I'm following order of operations correctly, right? So I'm going to take the change in total revenue, so the current total revenue minus my old total revenue. I'm then going to divide that by my new quantity minus my old quantity. That's just change in total revenue divided by a change in quantity, which gives me my marginal revenues. Okay. I'm then going to copy that down, and it will do the calculations for me very, very quickly. Now, one thing that I want to point out here is how do I find the slope of my demand curve? When I have demand, I've got price and quantity, so it would just be the change in price divided by a change in quantity. So here, if I've got these price quantity combinations, I could use any 2 points to calculate the slope. So here I simply took the change in my price divided by a change in my quantity. I get a slope of negative 0.5. Now, I told you that marginal revenue is always going to be twice as steep, or the slope would be twice as steep as demand. So if I know the slope of the demand curve is negative 0.5, I know the slope of my marginal revenue curve must be, well, that times 2 would be negative 1. Now, I didn't put multiply by 2 in this cell. What I actually did was use those marginal revenue values I came up with. If I did them correctly, I could look at the change in my marginal revenue divided by a change in quantity to tell me the slope of my marginal revenue curve. If I do this, hopefully it's the same as taking that slope of the demand curve and multiplying it by 2. Sure enough, it is. Okay. So this just kind of supports something we were talking about earlier with some actual values. Now, how would I calculate average total costs? Oh, use this the last 2 modules. That would simply be what? Total cost divided by my quantity. Right? So I've got my average total cost here. Just to kind of revisit some things, although this isn't an Excel file, what quantity would represent the efficient scale of production? Or what quantity would a perfectly competitive market get to in the long run? It should be where my per unit costs are at their lowest. Where are my per unit or my average total costs at their lowest here? Looks like it's at a quantity of, so 18.2, quantity of 40. So we know that would kind of be where my per unit costs are at their lowest point. Now, we're going to use this later on, but we'll kind of progress to the next column. How would I calculate my marginal costs? That's a change in my total costs divided by a change in my quantity. Okay? So I can calculate my marginal revenues and my marginal costs here. I now can use a slightly different way of calculating profits. We said, what's the other more general form we've been using in all class today? My profits are equal to the quantity I'm selling times the difference between my price and my average total cost. Right? And the reason why we can use this price is because the monopolist always goes up to the demand curve to set the price. So here I've got my profits. Hopefully, they match up exactly with using the other form of the equation. You go back to module 9, I actually rewrote the profit equation, just showing that you're just rearranging things, taking total revenue minus total cost. You can rearrange that into the form quantity times the difference between price and average. Okay. Now, I can eyeball this if I've done it this way. Where are profits at their highest point? Looks like right here. Okay. Now, if instead of eyeballing this, what should be true? A quantity that maximizes profits should also be where marginal revenue is equal to marginal cost. Now, if I don't have a truly continuous or every quantity in between, there might not be a point where they're exactly equal. So what I did over here, and I wouldn't expect you to do this like on a quiz or exam, but I used an if statement that just said, okay, if the marginal revenue is greater than or equal to the marginal cost, put a 1 here. If not, put a 0. This means like if it's a 1, I should be producing that unit, right? So I did that, and what you see is, okay, yeah, for a quantity of 8, marginal revenue is above marginal cost. Produce that unit, right? I'm making money. Second kind of quantity of 16, marginal revenue is above marginal cost. I should keep producing. Sure enough, my profits are going up. I continue to do that up to this quantity of what? 56. Marginal revenue is still above my marginal cost. I should produce that unit. Now, they're not quite equal, but that's the last unit where marginal revenue is greater than or equal to my marginal cost. If I then increase production to 64, marginal revenue is below marginal cost, and sure enough, what's happening to my profits, if I did produce that, they'd be going down. Doesn't make any sense for me. I want to be producing where total profits are maximized, which sure enough ends up being at the last quantity where marginal revenue is greater than or equal to marginal costs. So this table, using actual values for the demand curve and cost, support all the things we've set up to this point. Now, one more thing I want to point out here, and it's not quite in the table, but it helps, right? When we're thinking about these concepts. For every quantity where marginal revenue is positive, right? What must be true about the elasticity of demand? It should be. So we said as long as my marginal revenue is positive, we must be on the elastic portion of our demand curve. If you wanted to, you could actually go through, calculate the percentage change in quantity, percentage change in price, and prove to yourself that this is where demand is elastic. Now, if I ever look at negative marginal revenue values, this is where demand is becoming inelastic. I must be on the inelastic portion of my demand curve. Okay. Now I think I left some slides in here, or some columns in here. We'll think about the perfectly competitive market next class. But, you know, this is just a good way to see like how you would actually practically do this. You're not going to simply sit down and make these calculations quantity by quantity, you know, do this by hand. In fact, you could probably do something instead of using like these columns, you could do something completely continuous and using actual functional forms, taking derivatives, things like that. But this is a nice way to kind of display the data and prove what we've been talking about actually takes place when we're looking at an actual demand curve and actual total costs. One more thing I did want to mention here, just revisiting things to kind of hopefully solidify them. What do I know I'm in the long or the short run here? So I'm in the long run, what should my total cost be? In the long run, everything is variable. So if I produce nothing, my total costs are 0. Sure enough, if I produce nothing, my costs are 0. So I will kind of save this and we'll kind of pick up in this next class. I'll eventually end up posting. I posted the complete slide, but we'll kind of pick up here in class and eventually get to that complete slide. So before you kind of pack up, get out of here, another thing that I wanted to mention is after Thursday's class, we'll have that next module quiz, next top hat reading, and I'm going to post that fourth Canvas discussion. So we'll talk a little bit more in depth about that on Thursday, but it's going to change from the other ones, right? So I mentioned this last week. If you guys do stuff like this, do you think this is going to help you out in like job interviews? And okay, just give me a minute or two. Once again, this is a consistent theme throughout the semester. If you just listen, we'll get out of here earlier. Now I have to go through this little spiel, right? So I'll post that fourth Canvas discussion. Now, I'll also give you a word of advice, not just for this class, but classes moving forward. So it's going to incorporate the use of AI, right? And essentially what it's going to do is it's going to have you give me your prompts, the output AI gave you, at least summarized, and then your kind of response or analyzing that response that you got. So I know that I shouldn't say all of you, but the vast majority are using AI in the quizzes and things like that. It's okay. And I know in other classes, you're probably using it for projects, etc. If you want some advice from me, and kind of as I'm myself thinking about I've taken current courses on how to incorporate AI into teaching specifically, and my use of AI, the way that you should be using AI is a learning tool, right? So if you're just using it, okay, I've got this quiz question, give me the right answer. Are you learning anything? No. I don't care if you do that to get the correct answer and try to get the points, but that's not going to help you when it comes to an in-person exam, right? So how to use AI as an actual learning tool to help improve your performance in this class and other classes on like your exams and in-class assessments is what I would do is look at the question, try to answer it myself, then use AI, right? If AI varies from what I came up with, don't just trust it, right? In fact, AI, a lot of times in the AI discussions, they call it hallucinations. It'll give you the wrong answer, right? And it has to do with like the prompts you give it, the material that it's pulling from. It just gets things wrong sometimes, right? And in fact, with graphical depictions, it's wrong a lot more often. So I would try to solve it, see what AI gives me, and then as an additional check, if it varies from what I came up with, you yourself should have a third step, which is check AI. Look at its response and see if you can identify any obvious errors that it made. I have another course where like people are clearly using AI to do these problem sets, and they are so wildly off that if they were in class for even 5 minutes, they would know that AI's answer is complete bullshit, right? So that's the third step that to really help you not only get the answer more likely to be correct, but also to learn. So I got it wrong. AI told me it was this. Is there anything I can identify very easily that AI is getting wrong? Well, that means I'm using and thinking about what I know to check AI, right? So in that and checking out, I'm actually learning more than simply taking what it told me as gospel, right? So I would try to do that in every course you're using it in. Work on it, have it tell you the answer, check it as the third step. That's really going to help improve that learning process and make AI a real useful tool, right? I think as you're thinking about moving out to the job market, all of you are going to be using it. I mean, if you're not, it's going to be like not using a computer, right? Severe disadvantage, right? So we need to know how to actually use it effectively. And I think that third check, a lot of people just fail to do it, right? You look, okay, what do I think? What does AI tell me? All right, that's the answer. Check AI. It makes some very obvious mistakes and things you could identify. And in identifying that, you're relying on your own knowledge that's helping your learning process. So I probably went on too long, but I'm trying to help you out. I'm also trying to kind of like help you out in the context of that next Canvas discussion. So hopefully after today, it's going to be a little bit warmer out. So enjoy the nice weather tomorrow, the rest of the week. I'll see you guys on Thursday.